Hey guys, so today we're going over discrete random variables and we're going to use the context how many children are in your family. So because I'm not doing this with you, I just have some data collected from first period. But here it is, the probabilities of having 1, 2, 3, 4, 5, and so on children in your family are listed right here. So go ahead and copy this down. And then take a second, pause the video, and try to complete questions 1 through 7 with your neighbor. This video is only going to go over the important ideas like I do in class, so it's not going to go through how you answer each question. So make sure you take the time to pause, try to answer 1 through 7, and then unpause and watch the rest of the video. All right, hopefully you've paused and tried it by now. I'm going to go through this. Question 1, is this a valid probability model? Hopefully you said yes, because the probabilities all sum to 1. And remember, there's a second thing that we look for too, and it's that all probabilities are between 0 and 1. So remember, we cannot have negative probability, so that's another thing that we look for. Now, is 5.7167 a possible value for x? No, you can't have part of a child, a 0.7167th person. You would have a whole person. So that is why this variable, x, number of children, is what we call a discrete random variable. So that's our whole main idea for today. Discrete random variables are usually whole numbers, and they're used for counting most often. So like the number of children, the number of electives that you take, the age that you are, different things like that would be discrete. Now you should have made your histogram here, and there's some important things to remember with your histogram. You always want to label, so labeling the vertical axis as probability and your horizontal axis as the number of children. And then it did ask you to describe its shape. So for this one, hopefully you noticed that this was skewed right, because most of the data is on the left side. And then I just want to add a point here that it has a single peak at 3. So kind of just telling, explaining that 3 was the most likely to happen. All right, so for question 4, when it says describe in words, hopefully you put something like the probability that a randomly selected student has 3 or more children in their family, because it says x is greater than or equal to 3. And that probability based on this data was 20 out of 28. Now 5 is a little bit different because it says the probability that x is greater than 3. So this is strictly more than 3 children, and that probability would be 11 out of 28. Now in question 6, we were finding the average of just the x values that are in our table. So the average of 1 through 8 is 4.5, and for question 7, does this value tell us the average number of children? No, it does not. 4.5 is just the average of the numbers, but that doesn't take into account that more people have certain number of children in their family, right? Like a lot of people chose that they had 3 number of children in their family, and this 4.5 doesn't account for the fact that there were more people in that category. So how could we actually find a better mean to represent this data? What I'm going to do is I'm going to take the data from the table and I'm going to multiply each x value by the probability of that x value. So we're going to do 1 times 0 over 28 plus 2 times 8 over 28 plus 3 times 9 over 28 plus 4 times 5 over 28, plus 6 times 2 over 28. Oh, I skipped 5, so also plus 5 times 3 over 28 plus 7 times 1 over 28, and plus 8 times 0 over 28. Again, 8 and 1 are not necessary because they are just multiplied by 0, but just so you remember where that comes from. So if you were to plug this into your calculator, you should get an average of 3.46. And we do not need to divide our sum by the number of numbers that we've added because we're multiplying by the probabilities. So it gives us the mean right away. Now to write this as a formula, the mean of x is equal to, we're going to use the summation notation. So the summation of xi times pi. And this is the mean, but it also has a new name now in probability, and that is that this tells us the expected value. So we expect, based on the probability, that you would get the average. All right, so on to the important ideas. The first one is about a probability distribution. So this is the table that we have up in question 1, where you have your x's, and then you have the probability of those x's listed. And this we get when we have discrete random variables. So remember these, and this is an interesting definition. It says takes a fixed number of values, which means that you can't have any value you want, right? It's only of these fixed set of numbers. So out of a fixed number of values, and these values occur with gaps between them, right? So like 1 to 2 to 3 to 4, there's gaps in between those whole numbers, right? We're not including all of the little decimals. All right, learning target number 2 is about a histogram. So for the histogram right here, remember our vertical axis is probability. We want to make sure we start at 0, and then the horizontal are the values of x. Oh, and the last thing is the mean or the expected values. In this formula, the mean equals the summation of xi pi. And that really just means, like, this is x1 p1, x2 p2. It just means that you're taking each x value and you're multiplying it by its probability, and then you're adding up all of those different values you find by multiplying. All right, so take some time to do the check your understanding, and a key will be posted for that later on.